Hi, good afternoon. We hope you enjoyed the panel on systems engineering modernization. I'm Nicole Hutchison, and I'll be your track chair for the rest of the afternoon. This is the Human Capital Development track. It's where we talk about all of the unique skills required for systems engineers and how we go about building those skills. So our first presentation this afternoon is going to be on DAU digital engineering simulation. So interestingly enough, I am introducing myself, but also I would like to introduce Mr. Paul Wach. Paul is a graduate student, or excuse me, a PhD student at the Virginia Polytechnic Institute and State University, more fondly known as Virginia Tech. And Paul will be teaming with me on this presentation today. So please join me in welcoming Paul. Normally, as track chair, I have several questions queued up for each presenter based on their materials, but it would be oddly self-serving for me to ask myself questions. So please put any questions you have into the chat, and we'll look forward to answering them. So thank you, Paul, and we'll go ahead and get started. All right, so what we're going to go over today is just some background about what we're doing in this task, providing the broader context of what it is we're trying to achieve within the space of digital engineering, talk about the vision for our project and the CERC portfolio that will help to feed this task. So one of the things that I particularly love most about the CERC is we're a collaborative network of 22 universities, but we also collaborate within our projects. So you probably saw on the intro slide, this is a collaborative endeavor between Virginia Tech, Stevens, and the Georgia Tech Research Institute. So we've got a great team of folks working on this, but we're also leveraging work that has happened previously in the CERC or that is ongoing. So it's one of the great things about the really collaborative environment that the CERC provides. And then I will hand over to Paul, who's going to go over more of our detailed results with you. All right, so we're going to start with just a little bit of thought and insight about what digital engineering is. You may have seen this image before. It's from the 2018 DoD Digital Engineering Strategy. And the main point here is that there needs to be a source of truth from which we can integrate and talk across a variety of models. And we need to have one place where we can go and understand this is how our system is viewed and working today. So that is the vision of what we're trying to work toward. Next, please. And the way that the DoD Digital Engineering Strategy lays that out is in 5 steps. So there's one on formalizing the use of models, one really focused on, again, this idea of authoritative source of truth. How do we establish that? How do we maintain it? Using innovative technologies as part of this space, creating an infrastructure in which we can perform digital engineering work. And then in the diagram, you see the gray that underpins everything. And that's really the workforce transformation piece that we're talking about here. This is very different than how we do business. This is not, we have a PDR and then we have a CDR and then we go through these big reviews that are primarily document based. And even if those documents are digital documents, they're still documents. This is not new. This has been a transition that I started hearing about when I attended my first INCOSE conference in 2008. So it's a transformation long in the making, but the DoD is really trying to embrace that and to understand that people need to enable them to work in this environment. And not just the engineers or the systems engineers, but there are some baseline skills that everyone's going to need. And so really this task is designed to create a simulation environment that can be used for education and training so that it's not, I'm learning from a picture of a PowerPoint, I'm actually interacting with models and simulations to gain those skills. And again, so this is goal 5. This is the space that we're working in about that workforce transformation. The cultural piece of it is also very important. The CERC has done some work around culture and cultural transformation for systems engineering, which we can talk about if there are any questions at the end. But the main thing is it's really goal 5 for the strategy that we're working on here. So this is our mental model of what we're trying to do. We start with a DoD workforce, and what we're trying to do is get that workforce in a position that we can enable successful digital transformation. And again, not just for engineering, but across the acquisition cycle. So we're talking about digital acquisition, not just engineering. So the way, sorry, if you could go back, thank you. So the way that we think about this is there's the environment in which all of this happens. That is built upon a backbone of data. So there's data about programs, data about students, all different types of data that we have to keep track of. There are simulations, which we call case studies, that are very specific instances, types of systems. If you've been with us yesterday and today, you've heard about systems like Skyzer and Silverfish. Those are examples of system models that we want to bring in into this simulation as case studies so that students can work with those models to learn and understand them. There's pedagogical approaches. How do we actually teach and help people embrace and learn these concepts? And then finally, all of that has to feed into the metrics we use to determine, are people actually changing? Are they evolving? Is what we're doing in training and education actually helping? So all of those things are intended to come together to help us achieve specific learning objectives, which again are supposed to help us increase our digital engineering skill set to improve the probability that the DoD will successfully move through to digital transformation. And again, you know, there are a couple of things that are existing that we're already using. So that's our general mental model of what we're trying to do. The concept that we're using is what we're calling a digital textbook, though I hope you'll immediately see this probably doesn't look like any textbook that you're used to using. Again, we have a number of case studies, what we're calling case studies that we're developing, things like the Skyzer and Silverfish models, that students will be able to go in and we'll have a specific scenario, you know, hey, we need you to look across these 3 different views of your system to make a decision, or you need to be able to find this information. We think about this, again, not just for engineers, but for anyone who's going to have to work in this digitally based environment. And so we have considerations for foundational digital literacy, which is our starting point. So you could imagine a PM has to be able to find information and make decisions about it. You could imagine that a contracting officer needs to be able to find and confirm information, in addition to engineers who are going to have a lot heavier interaction with models. Again, we have the specific student interaction. So we have demos, tutorials. There might be, again, exercises like I talked about, specific instructor-led exercises or asynchronous, but we'd have a collection of those that are linked into the models. And so what we're really talking about is a very modular architecture for this environment that we're trying to create. And then again, we'd have a number of learning modules to support all of this. And there would be a pathway you walk through these things that we would eventually build into a credential. And so this work is sponsored by the Defense Acquisition University, and that is the path that they are on, which is building credentials and micro-credentials. So we would fit into that environment by helping, again, come up with the more experiential piece of their credentials. And again, all of this comes together in a way that's supposed to provide the ability for students to achieve their learning objectives, which is really all about building their knowledge, skills, and abilities. I mentioned that we have a number of projects going on at the CERC. I won't read through all in the set box. Is really the modeling environment that we're talking about, what we're doing in this task for DAU. We have a number of things we've developed, like the Digital Engineering Competency Framework. We have work that we did on micro-credentialing for digital engineering, AI and ML, and data analytics for DAU as well. I mentioned the Skyzer and Silverfish projects and the tasks associated with them and everything they've learned in their research. We're working on ontology and digital engineering metrics, and all of these things are valuable for us to understand what is it people really need to learn and achieve to be able to function well and be effective in a digital space. The one thing I think I have left to say about that is when we say digital, we've actually come up with some different vocabulary. So there's digital, which is almost the, think of that as the translation of what we're doing in document-based into a modeling environment. So for example, there are models like Skyzer where you can actually say, well, I still need a requirements document. I want all the good things about models, the ability to track changes, to see how things flow across the system, to test things in a simulated environment, et cetera. But I still have to have a requirements document. And you can actually create a requirements document from that. That's kind of digital transformation. We are using the term digitized transformation and digitalized transformation. And what we mean by that is not just, taking something that is quote unquote paper-based and moving it into an electronic version, but actually taking advantage of the different approaches that you can use in digital engineering and different ways of doing things, which again is part of that major culture shift. So again, just a few examples of things that we're doing here. The digital engineering competency framework. I won't go into details because I want to leave plenty of time for Paul, but happy to answer any questions about this. These are the main things here. This is the Skyzer model, which again, you may have heard in other briefings yesterday or today. The Silverfish model itself. And so the main point here is that we are building on all the good work that's been done at the CERT. We're not reinventing the wheel from scratch. And this is just some of the work that came out of the DE metrics task on benefits of digital engineering. And again, to have that effective workforce transformation, what we're trying to do is really be able to actualize these benefits. With that, I'm going to turn it over to Paul, who's going to go over some of the detailed results. Paul, floor is yours.
Thank you, Nicole. So here we go. All right, so as Nicole alluded to, we've framed a lot of the curriculum that we're working on around 2 case studies. One of those is the Silverfish model, and the Silverfish model is really created. If you had the pleasure of seeing one of Peter's Beeling's talks today or even yesterday, it's a notional system that's designed for cyber resilience. And the other case study that we're working on is Skyzer. So if you saw one of Mark Blackburn's talk a couple of hours ago, then you know what that is. And so with the Skyzer model, it's a notional UAV search and rescue mission. And rather than just reinventing the wheel on these, as Nicole alluded to, is that we're taking what we have so far and converting it into some type of curriculum that we can use for DAU. So for this slide, I really want you to think about, what do you think of when you heard the term system model or even the system model? One of the things I've seen in practice and across the literature is a reference to the system model. And what I've realized in the process of going through the Skyzer model is that there's not the system model. There are several system models. In fact, when I started creating and looking at all the different Skyzer models, there are at least 24 models within the Skyzer MBSE ecosystem. And all of these actually need to interact in order to actually form a coherent picture of the Skyzer system. Another thing that I kind of want to point out on this slide before I go to the next one is that the last 4 on here, those are really extensions to the systems modeling language, and those are important, and they're critical aspects to actually using MBSE, especially within the context of SysML. And so that's why I get to this next slide, where it's important for students to understand, and even for decision makers to understand that there's an important aspect to the modeling language that you actually choose, and the fact that it may have and require some sort of extension for your particular use. In the case of Skyzer, yes, it's built on top of the system's modeling language, but we've created a profile, which is an extension of SysML, that provides a specific context and is really generally only relevant for Skyzer itself. And now that doesn't necessarily mean that it can't be applied to other cases, but is created with the intent of being used within the Skyzer ecosystem. And other things that you might see in practice, or like the unified architecture framework, that's something I've used in practice, the business process modeling notation as well. You may even see standards that are produced as models. One of the standards that's actually part of the Skyzer MBSE ecosystem is the 516C TAC airworthiness. And so that's a standard that we've imported into the Skyzer models so that we can actually have that in reference to it and build the Skyzer models based upon this. And so the important note of this is just remember that there may be extensions that you have for, in particular, to the SysML language that's specific to your project or even to your organization. Part of what we've also done too, in order to map the Skyzer models to the systems engineering V, was just understanding, one, do we actually have a representative sample of the systems engineering V? And generally speaking, the answer to that is yes. And you can see some of these with the mission model, the systems model, both on the government side and the system model on the contractor side, as well as some indication of verification, validation, test, and evaluation. But one of the interesting facts that we learned in the process of mapping to the systems engineering V is that you have some models that they don't really exist with just in one part of the V. And so some examples here are like the airworthiness model and the system evaluation model, as well as the estimation model, where those, yeah, they're relevant to the right side of the V, but they're really something that's created at the left side of the V. And similarly, we also started mapping the Skyzer models to the acquisition lifecycle. In this case, we selected the major capability acquisition lifecycle. And there are models that they exist pretty nicely within a part of the acquisition lifecycle, but that's not necessarily true for all the models. In many cases, they're just going to exist kind of across the acquisition lifecycle. So yeah, you have a statement of work, something that maybe you're going to evolve. The same goes with the evaluation and estimation models, which I talked about with the system engineering V. But one of the particular one that is most relevant across the systems or across the acquisition lifecycle is the cost model. And that's something that you start at the beginning. And in fact, within the Skyzer ecosystem of MBSE models, it really has an integration touch point with all the other Skyzer models. And that's important because that is necessary in order to update and understand the cost of the overall Skyzer system. And we're also using this just from a teaching standpoint of mapping to specific curriculum and understanding where we actually have the right coverage and where maybe we don't. And if we don't, then maybe we need to develop more curriculum on top of that. Some of the curriculum development that we've worked on too is just defining workflows in terms of some of the digital artifacts that we have. And so going back again to the Skyzer model, one of the things I've just been working on in terms of a workflow is the idea of, okay, you have a basic scenario where a government individual is going to need to provide something to the ecosystem. There's going to be some sense of a review, followed by a approval, disapproval, comment, or something like that. And So to start off this, and for looking at inputting information, we're using SysML because that's what Skyzer is built on, and Cameo. And just as an initial example of what we're working on, we have the measures of effectiveness, which in this case, in an actual classroom scenario, a student would need to actually go into the Cameo model and define these measures of effectiveness within a block definition diagram. And then in between, actually, there's a Open MBE that's actually on the other side of the Skyzer ecosystem. So Open MBE enables the export of the models and into a format that not everyone needs to read. I mean, some cases, yes, you can export the actual diagram itself, but maybe the individual only needs to understand a table that looks at, say, the measures of effectiveness, for example. And so OpenMBE and the idea of the documents that are generated from the model enables this conversion to a more digestible format for the correct individual. And what we've done in this case is that, and getting back to the digital sign-off, and in this case of the measures of effectiveness, is what I'm saying is that we're using this table that's in the OpenMBE environment to actually have some sort of digital sign-off. And what I'm saying with this chart, or suggesting, is that you could have an example where you have a subject matter expert approve and followed by a disapproval or rejection from the chief engineer. And within the OpenMBE environment, there's a mechanism to add some comments. And I see that I'm getting close to time, so I'm going to keep going. Let's see. So cyber resilience. So this is the Silverfish side of things. We are using this. And one of the things that's a little bit different about the Silverfish side is that it's actually in Genesis, which is a different MBSE tool. And we have some of these models that are constructed for the Silverfish. The Silverfish is actually contrary, it's not a search and rescue. It's actually a deterrent, where you have a minefield, a notional minefield that's used to deter physical attackers, or in some cases, in the case of the UAV observing an attacker, there's an operator that actually can provide the command to explode the ordnance. And for the cyber resilience side, which is most of what we're developing the curriculum around, the Silverfish uses the system theoretic process analysis to actually understand and assess the risks. So since we are using Genesis here, it's a little bit different to map this to the systems engineering V. So instead of mapping specific elements of the Silverfish model, what we've effectively done is map the ontology or the meta model that's underpinned by Genesis to different aspects of the systems engineering V. So what we've done here is actually extended the meta model of Genesis to create specific ontologies and meta models for the mission awareness, design simulation, and validation test. And the part of the difference between this and the Skyzer model is that this is not unique to the Silverfish. This is something that can be transferred to other use cases. And I think I have a couple more slides here. So what we're partially doing too is tracking this within a design or dependency structure matrix. And what that's enabling us to do is to identify areas that we're covering or maybe not covering. I started doing this largely just to map the different Skyzer models to different Skyzer models and understand how the ecosystem was internally interacting with itself within the MBSE environment. But we're also using this again for things like the acquisition lifecycle, to point to how different career fields may use the different models. So an example might be the Skyzer statement of work. And so someone in contracts would want to understand that particular model. And the same goes with the credentials that DAU is working on. So we're in the process of mapping these models to different credentials. All right, let's see, 2 more slides. So this one I'll touch on for a moment. Nicole mentioned that we have the idea of a digital textbook. And the idea in the future is that and this is more of the end goal, is that we have some environment where students can interact synchronously or asynchronously, and we can come up with several scenarios where they can really hopefully fail within this environment rather than fail in the real situation, given, say, budget or test results, and go through these scenarios, interact with other students in other career fields, or interact with instructors as well. And this is the last slide that I have, and then we can open up to some questions. So in the process of actually of going through and creating this curriculum and defining everything, we're keeping track of lessons that we're learning. The way we perceive is that if there's something that we're struggling with it, then some student is also going to struggle with that. One of the questions that we've actually asked ourselves, that DAU has asked us, and that I've also seen as practice, is what is the minimum DE ecosystem? And one of the ideas that we've come up with is, well, okay, is the DE ecosystem really just an ecosystem of services where you actually have some core component that interconnects things? And so if you're not familiar with the concept of a service, always think of a service of saying, if the actual system is destroyed, then the services may still exist. Whereas the core component would be something like the MBSE system. And what I'm seeing both in practice as well as in academia and the literature is that it suggests that maybe MBSE is the or a core component to digital engineering and to the ecosystem. And by that, what I mean is that if the MBSE part is destroyed, then there's significantly or notably less coherence within the ecosystem itself. And that certainly seems to be the case within the Skyzer model. And that is my last slide. So this is our team. Again, we have a large contingent from Stevens, as well as Virginia Tech and Georgia Tech.
Thanks very much, Paul. And yeah, we wanted to make sure that we acknowledge the team. So Paul and I are the two you're seeing today, but as we said, very large team of people. So thanks to everyone who's working on this task and making it better, making us do well. We have 2 questions so far. Please, if there are any others, put them in. We'll answer Beth Wilson's first. Are the DAU courses available outside of the DoD? Unfortunately, not at the moment. There's some discussion as to whether they become a little more open source and available, but right now they are DoD specific. So Dr. Peter Beeling, who some of you might have heard yesterday and today as well, said, would you expand on the educational background or experience that you were assuming and or hoping for? Paul, would you like me to start, or would you like to kick that off?
I'll start. And so generally the idea is that we're looking at a tiered approach for different students. And so I wouldn't say that we're necessarily making a full assumption on the educational background of each student. I'd say that we're assuming that there's going to be a range where you have some individuals that have absolutely no knowledge and maybe even up to high school education, whereas others may have advanced degrees. And we're also depending on the concept that there are specific career fields that each individual will need. And within all of these combined contexts, you may have some general entry level where you're just showing like basic diagrams and understanding that things have to fit together to create a coherent picture. And there may be a middle tier where there's some understanding that there's some mechanics behind the working. And on the other hand, you have some real hands-on training where people are going to need to understand and create these models themselves.
Well, I don't think I have anything to add on that, other than, I mentioned we're trying to take a more modular approach in how we put these things together, and it's exactly to Paul's point, because there is no standard expected background, so we need to have a lot of flexibility. DAU has created a course in digital literacy, which they are in the process of piloting now, and that's intended to help the workforce have a more consistent baseline. Beth, you had a follow-up. You mentioned micro courses. Are you working with stackable badge concepts? So the DAU micro credentials, I think, are looking at that. It's not clear at the moment whether DAU is going to go further down the road of micro credentialing or stick with more, not monolithic, but a little bit more traditional credentialing. So I don't know the answer to that more clearly than that. Paul, anything to
add? Nothing I can add on that. I saw Peter asked another question, so.
Oh, okay. So another question from Peter Beeling. Your case studies were drawn from 2 different tool environments. Will you or DAU be picking a single tool, or do you aspire to support multiple environments? And the short answer is, ideally, we would like to support multiple environments because there is no one consistent environment being used across the DoD. So, certain services have certain tools that they like better than others. Some are still experimenting more. PMOs are trying to figure out which tools make sense for what they're trying to do. So I think the more we have flexibility in what we're creating, the better training can be tailored. I also think that some of the most important foundational concepts for digital engineering and even digital literacy to some extent are the idea of abstraction. And if we can show you that it's the same information, the same general processes, just done slightly differently in different tools, I think that will really help build those abstract thinking muscles, if you will. Paul, anything you'd like to add there?
I think you actually summed it up pretty well. The little bit that I'll add is that in practice, I've seen where some places people are using Genesis, some people are using Innoslate, others are using IBM Rhapsody, and then I see a large contingent that are using Cameo Systems Modeler. In fact, last week or 2 weeks ago at the AI workshop sponsored by the CERC, there was an individual that asked this question of, how do we always think of SysML as being MBSE? And I don't think everyone really does. I think that's just kind of a de facto that a lot of people think toward. And in reality, what we're going to have is just this combination of tools. And so what we do, and getting to Peter's point, is that we need to make sure that they actually do speak together. And part of what we're exploring is the idea of an information model that has commonality across the different tool sets so that they can integrate and so that we can train students on a minimal set of information that they need to understand.
Thank you, Paul. So one last call for any further questions. We'll give you just a second. Otherwise, I want to thank you all for your time. You're more than welcome to reach out to me or reach out to Paul. We're happy to have further discussions, answer any questions you might have. We will take a short 2-minute break and restart at 3:10 with Captain Bill Shepard. So thank you all very much. Have a good afternoon. Paul, thank you for your time.
Thank you.
Take care. All right, folks, welcome back. We are in the Human Capital Development track, and we are going to hear about the Capstone Marketplace, which is one of, honestly, my favorite projects in the CERC. I think they do great work, and the best part is there's a lot of student engagement, so always fun. You're going to hear from Captain Bill Shepard today. He is a retired Navy SEAL and United States astronaut starting in 1990.